Morning, everyone. I'm thrilled to be here with you today to explore messaging queues with a spotlight on Amazon SQS. I'm Ravi Maurya, an associate software engineer. I have the pleasure of introducing my co-presenter Ronak Jain. Ronak is also an associate software engineer at Mindbowser. So the first half of the webinar will be covered by me, and the second part will be covered by Ronak. Let's first quickly see what all we will be discussing in this webinar. We will start right from the basics of messaging queue. Then we will discuss about SQS and its pricing, how SQS works of SQS. Then we will slowly move toward complex topics like long polling, short polling, dead letter queue, and along with the demonstration. Let's first discuss what is queue. Imagine a queue as a line at your favorite coffee shop. Right, it's a line of people, and the first person to join the line gets their coffee. Just like in queue, where the first thing you put in is the first thing that comes out. This concept is also called as first in, first out. There are many examples of queues like hospitals, banks, ticket reservation counters, etc. Queue is widely used for performing tasks like CPU scheduling, printer spooling, and sharing data between applications. So I think this was a very basic overview of queue. Components of messaging queue. So there are three components involved in messaging queue. First is the producer, second is consumer, and third is the message. So producer and consumer are different applications, or we can say services. Now, because they perform different operations, they are named as producers and consumers. Producers basically keep generating new messages, and consumers process these messages. Messages serve as a communication medium between producers and consumers. So let's take an example of Domino's or Pizza Hut to make it more simple. Let's say you go to a Pizza Hut and you say that to cashier that you want a regular size pizza with onions, tomatoes, and mushrooms with extra cheese, and want to take away. You don't want to have it there. Okay. Then cashier places this order. Then the cook or chef in the kitchen gets this order and starts cooking. And then after your order is cooked, you get your order, right? Similarly, cashier places multiple orders for multiple customers. Okay, and chefs working in kitchen process each order one by one. In this example, cashier is a producer who is constantly producing new orders based on the customer's requirement, and chef is the consumer who is cooking according to the order placed, and message is your order details. Like you can see here, we have a typical message format. Like you can see, the order number is 20, size is regular. So this is how the whole message can be described, and this message is sent from a producer to consumer, that is from a cashier to chef. And chef uses these messages to see what he has to actually do. These messages can be a task or instructions. So messages are typically in JSON format, but it can be in any other format also, like XML, video, audio, or document, depending upon the messaging queue service we use, or what our requirements are. Note that it is not necessary that producer and consumer application is built using same language. Producer application can be in Java, and a consumer application can be in Python also. So I hope we are clear with the components of messaging queue. Okay. So what exactly is a messaging queue? A messaging queue is a communication medium between consumers and producers. Messaging queue is a shared queue between producer and consumer, because producers and consumers can share messages easily and in order as they were sent. So a producer can insert messages to a queue and consumer fetches it from queue one by one and processes it to perform tasks like generating analytics, notifying users, or any other task like processing and converting the data, etc. So let's take an example here also so that we can understand it and some of its use cases. With the first example, uh, use case one. So in the first example, we will consider two use cases. So consider an e-commerce application like Amazon or Flipkart. Okay, now I want to buy a product. Let's say I want to buy a wristwatch. I place an order, complete the payment. Now the server, after validating payment, sends messages to queue with my order details. And this server will be a producer because it is producing messages after successful order order is placed. Okay, now another server can process this message to generate real-time analytics like which products are trending this week or maybe most sold products or trending brands and promote these trending products more. And also can notify users by push notifications that XYZ product is trending. We have great offers on this product. Okay. In the same example, we will also consider a second use case could be, let's say I placed an order, then producer will send a message saying that this is the order, this is the delivery address, total amount is 2000 and expected delivery date would be 1st September. So now the consumer application will fetch this message, can fetch data, users, email and mobile number from database and send confirmation notification on message and mail to users. So it can be used as for notifying users also. And whenever an order status is updated or to shipped or out for delivery, users can be notified in the same way. So let's take another example of how data can be processed using SQS. Let take let's say you want to upload a video on YouTube. YouTube allows you to upload in any format like AVI, MOV, FLV, or MP4. But YouTube also says that it will convert the videos to MP4 for better quality and because it is compatible on every device and operating system. Okay. Now consider I have uploaded a video in AVI format. Now the producer application will send a message to queue saying that I have received a video in AVI format. Now you have to convert it to MP4 and this is the location where you can find the video. Now the consumer application is constantly listening for new messages and as the consumer gets this message, what it will do is it will fetch the message uh, and now it knows where the video is stored. It will convert it and replace the original video. And please note that there are millions of users simultaneously uploading videos, and this is how they are being processed. I mean, I don't know whether YouTube actually does it, but you can take this as an example. Okay, I hope now we have basic understanding how messaging queue helps in communicating producers and applications and some of its use cases. So let's see few more characteristics of messaging queue. Consider consumer need not be free every time to process messages. They can process messages anytime whenever they get free or uh, even if they are down, they can start processing messages that they missed because of the downtime. And because of this messaging queue, now they can communicate asynchronously. They are not dependent on each other for communication. So messaging queue also helps in decoupling applications. It means it helps in breaking down big and complex applications into smaller components. In previous example, as we saw that uh, a bigger application like Amazon was broken into two parts, and these parts are no more dependent on each other. Order of messages is maintained in messaging queue. This means that message to be inserted first will be processed first. Note that there is no limitation on number of producers or consumers. So there can be multiple producers, multiple consumers sharing same queue, and they can work simultaneously. Talking about messaging queue providers, there are many options available like Azure Service Bus, Amazon SQS, IBM MQ, and Rabbit MQ. But for today's webinar, we will be discussing only on Amazon SQS, that I believe is the most used and efficient amongst all. SQS is a hosted queue service. Like we saw in messaging queue, the same queue will be hosted somewhere on the AWS, and this messaging queue would be used for communication between consumers and producers. Applications using SQS can communicate asynchronously, and it helps in decoupling application as the messaging queue was helping. So SQS and messaging queue are almost same, but with some extra features. SQS offers high reliability, scalability. We will see it in upcoming slides also. Now let's see SQS in more detail. Uh, Hosted messaging queue service, as I just said, SQS hosts messaging queue service on AWS servers. So we need not explicitly manage the whole infrastructure of messaging queue. So this has made it very easy to build and decouple applications. SQS replicates messages across multiple availability zones within a region, so which ensures that messages are highly available and minimizes the risk of message loss. So SQS is scalable because it can adjust its capacity depending upon the workload, ensuring optimal performance. Applications can communicate asynchronously using SQS because they are no more dependent on each other for communication. They are now communicating through a messaging queue, so they can perform their tasks as they get free or as the situation demands. So SQS basically provides two types of queues, standard and FIFO queue, which we will be seeing it in upcoming slides also. We can send messages up to 256 KB in JSON or XML format. But if we want to send large messages, then 256 KB, then we can upload the message on S3 buckets and share its reference using the SQS message. And SQS, as SQS is a AWS service, it can be easily integrated with other AWS services like SNS, EC2 Lambda, etc. etc. And AWS provides TKs in many different languages like Java, Python, JavaScript, Golang, C++, and many more. So it is easy to integrate SQS in applications. Let's discuss the costing of SQS also. So here we are seeing the cost of SQS in Ohio region. So here, as we can see, the first 1 million requests per month are free for all. So you all can sign up and start using it for free, and it is chargeable if request goes above 1 million requests per month. Also note that every API call to SQS is considered as one request, be it a send message request or receive message request, delete message. or any other action like changing queue attributes or getting queue attributes, etc. Uh, and also each 64 KB chunk of data is considered as one request. For example, if I make a single API call to SQS using 64 KB of payload, it will be considered as one request. And if I make a single API call with 256 KB of payload, then it will be considered as 4 requests and build accordingly. This is all about the costing of SQS. Let us now understand the working process of SQS. So the process of SQS is pretty simple and same as the messaging queue, but with some more features. Let's understand how SQS works. Consider the producers as Amazon server, like we did in last example. So consider producer as Amazon server, constantly generating new messages for new orders placed or whenever the order is cancelled or order status is updated. And consider the consumer as different applications which are sending notification to users through message and emails. Okay. Uh, so producers send messages to queue, and then messages are retained in the queue until they are fetched and processed by the consumer. Now the consumer will start fetching the messages from queue and process it to send notifications. Now whenever a message is received by consumer, let's say a message is received by consumer, let's say first message is received by consumer 1 for so the first message becomes invisible for some time, let's say for 30 seconds or 1 minute, and this time is called as visibility timeout. So now when a consumer 2 or 3 tries to fetch messages, they will not receive first message. They will receive second and third message. Okay. So now there are two possible cases, like what happens if message is processed and what happens if message is not processed successfully by a consumer. So if a message is processed within 30 seconds or 1 minute, that is before the visibility timeout expires, then a consumer will make a delete request for that message, and that message will be deleted from the queue. And if consumer was not able to process the message before visibility timeout expires, then message again becomes visible to other consumers. Now when consumer 2 or 3 tries to fetch messages, they will receive message 1, the first message, and they can try to process it. And this visibility timeout is configurable while creating queue. So the default timeout is 30 seconds, and you can set it maximum up to 12 hours, and minimum is 0 seconds. So now you might be wondering what is this long polling and DLQ. So DLQ is a dead letter queue, which is used for error handling. It stores the messages that consumers were not able to process. In case of message fails to be processed by consumers multiple times, then we can push that message to this dead letter queue, and we can later analyze, or we can write different applications to handle those error messages and debug those error messages and identify the reason behind the failure. We will be seeing DLQ and long polling in more detail in upcoming slides also. So next we have types of SQS, I guess. Yes. So there are two types of queues. First is the standard queue and FIFO queue. So standard queue is all about delivering messages quickly and efficiently, and FIFO queue is all about ensuring that messages are delivered exactly in the same order as they were sent, one after the other. And standard queue. So let's first see standard queue. Standard queue is designed for handling any amount of data. It can handle it can handle millions of transactions per second. Uh, but it also comes with some disadvantages, like it it offers at least once message delivery, that a message might get delivered twice to a consumer. So this is the disadvantage, that a standard queue can might deliver a message twice. It offers a faster message transfer with very low latency, which makes it suitable for applications where real-time processing of data is needed. So, and it is also cheaper than POQ. So it becomes the best choice for applications where order of message is not crucial. Like uh, take an example like of Pizza Hut, where you place an order first, but it is not guaranteed that you will get your order first. You might get your order uh, late also, and the person behind you might get the order first, because it might take some time in order processing also, or maybe you somewhere order is missed or something else happens. Now let's see PPOQ. PPOQ is designed in a way that it guarantees the order of messages. It means that it will send messages in same order as they were received in the uh, queue, without compromising much on speed. Means it is also faster, but a little bit very slight difference than the standard queue. Uh, it guarantees that message is delivered only once. So like we have in standard queue that messages might get delivered twice, here we don't have that problem. And it automatically eliminates the duplicate messages also. It automatically handles duplicate messages. And it also provides an extra feature, like we can group messages and send it in a batch. So a batch can contain up to 10 messages, and the order of messages within the batch is also maintained. Okay, it is slightly costlier because it offers some extra features, and it is more reliable than the standard queue. This makes it suitable for applications where uh, order of messages is critical, it is crucial, like in banking applications, in e-commerce applications. Okay, so this was all about types of SQS queue. The next part of the slide will be explained by the runner.
Okay. Uh, Hi everyone, I'm Ronak Jain. So I will be continuing from here. I hope you all can listen to me clearly. So Ravi has explained you all about SQS, its process, and the working of SQS and its type. But from here on, I will be explaining you all the features SQS has to offer. Okay. So first feature is long pulling and short pulling. Okay. Before understanding what long pooling and short pooling is, we will understand what pooling is. Okay, so we can say pooling is a mechanism that consumer is used to retrieve the messages from the SQS queue. Okay, let's suppose we have a consumer which can be an application or can be an service. Okay, the consumer is always and periodically checks for the new messages in the SQS queue. Let's say a consumer is checking at every 1 minute, like if there is any new messages available in the SQS queue. Now it can get that message and process them. Okay. Uh, Traditionally, actually, we have another approach, which is a push-based method, in which SQS is pushing the message to the consumer. Okay. Now, in this, consumer don't have to wait, you have to consumer don't have to pull the messages. Okay, but there is a slightly disadvantage in the push based method. That's why we prefer the pulling method. Okay, SQS pulling allows us to pull the messages at our consumer space. Okay, let's suppose consumer is not able to process that message, it is not that faster. Okay, and SQS has multiple messages. Okay, now our consumer can pull those messages at its own pace, so it makes it more scalable and robust solution. Okay, now we will understand what long polling and short polling is. Okay, so firstly I will discuss about short polling. Okay, whenever a consumer makes an request to pull the messages from the SQS queue, and in this condition we have two conditions. Okay, these two scenarios. In the first scenario, let's suppose SQS already has some messages available in the SQS queue. Now consumer makes an pulling request. What will happen? It directly comes with an response. Like, let's suppose you have some messages, you can now process them. But in the second scenario where we don't have any messages, still again in this condition also, SQS queue doesn't holds that API. It still directly says that the short polling consumer says you have no messages in the SQS queue. You can further try later. Okay, but in case of long polling, whenever consumer tries to make an request, a polling request, SQS holds if they don't have any messages to process them. It holds that API for particular amount of time that we can specify while making that pulling request. Okay. Now, uh, in case of short polling, the immediately retrieve the messages means consumer always get messages at an instant, whether it can be in with an message data, whether it can be no response data. Okay, but in long polling case it improves every efficiency. Let's suppose I will share with you in another example. Let's suppose we have two consumers, and both of them are sending polling request at every second for let's suppose a 1 minute of time period. Okay, in short polling case, as consumer is requesting 60 requests on that particular 1 minute, but in case of long polling, I specified 10 second of holding period. Okay, now the long polling consumer is creating six requests on that particular minute. Now we can say long polling is more cost optimized also, because it making less number of requests. Okay, and also reduces empty responses. Okay, so that is the major difference between long polling and short polling. I will share with you another great example, so you can get a better understanding of long polling and short polling. Okay, as a user, I in my mobile I have an application installed, and which name is where is my train. Okay, and I use it every time when I'm traveling to another city or another location. Okay, in that application, it tells me what is the updated and exact current location of my train. Okay, so let's say I'm on the detail page of a particular train, and there is a refresh button. Okay, whenever a user clicks on that refresh button, it goes to the server and gets all the updated data of that particular train. Okay, now consider two scenarios. In both of the scenario, one of them is a short polling case and another one is long polling case. Okay, whenever a user press that refresh button in short polling case, let's suppose I implemented a short polling method. Whenever a user clicks on that refresh button, now whenever user clicks on that refresh button, what will happen? That particular application makes an polling request to the railway server and checks for a new updated location. Okay, now if there is an updated location, it will directly say like you have this updated location, but in another scenario it will say no updates. Okay, but as a UI, as a user experience, what I will see whenever I click that refresh button, um, whenever I click that refresh button, okay, there is no loader. Okay, instantly I get the response, whether it can be some updated location, whether it can be no update data. Okay, but in case of long polling, what will happen whenever user clicks on that refresh button? Uh, Whatever developer has specified that holding period, okay, for that particular time period, the UI or refreshing or loading for that particular time. Now, okay, so let's suppose under 5 seconds, I get the response. Okay, now I will say like this is your updated location. In another scenario, even after that 10 seconds, there is no updates available. Okay, so in this case, after the 10 second of loader, I will get to see the no updates. Okay, so this is the totally depend on the user experience and user experience developer, what they want their customer to see. You can implement the long pulling, and you can also you can implement the short pulling. It totally depends on the developer and the requirements. Okay, so I think you all get to know what long pulling and short pulling is. Now we have another feature of SQS queue, which is delay queue. Actual delay queue is not a separate queue like our standard or FIFO queue. It's just an feature in a standard and FIFO queue. Okay, so let's suppose in a scenario where a producer makes an request to add any message in the SQS queue, and while adding that message, it is some delay seconds in that request. Uh, let's suppose producer added 10 minutes of 10 minutes of delay, and for that particular time period, the message is added in the SQS queue, but not going to visible for any consumer to consume that message. Okay, that is the delay queue. Okay, delay queue configured can be 0 seconds to 15 minutes. Uh, Before that, actually, I will give you an railway railway example where you can uh, actual see the actual physical example of a delay queue. Okay, let's suppose it's an 10 a.m. At every morning, and railway is opening its Tatkal ticket booking system. Okay, so for that particular time, railway wants all the resources to be working on booking those Tatkal tickets, not to do some other the stuffs like viewing all the messages and viewing all the tickets and all. Okay, so for that particular time, whenever a passenger makes a request to the server to book a ticket, it adds an delay seconds. Let's suppose it adds 15 minute of delay. Okay, so for that particular time, what will happen? Our railway server has another service called email service. Okay, which task is to process all the emails, and now let's suppose that email consumer is try to fetch all the tickets to send that particular passenger a confirmation email. Okay, but as a producer, I added a 15-minute delay period, and for that delay period, there is no messages available for the email consumer to consume that message and send that email confirmation. Okay, so after that 15 minute, now that email consumer is able to process that message. Mm, Uh, what it will do? For that 15 minute, now the hype is over. Okay, now now there are not that many users who are requesting to book a new ticket. Okay, now our servers, our resources can be allocated to that particular email consumer to process all those messages. So this is the another example that where we can use our delay queue. Okay, I don't know if they are using this method, but they can, like, it's a good example. Now there is an another feature of SQS. Ravi has explained some of it, which is dead letter queue. Okay, so dead letter queue now it is a separate queue rather than our like standard and FIFO queue. Now it is also in separate queue. What it will do, it helps the developer and debugger team to capture all the messages that is not able to process by the SQS queue or the consumers. Okay, uh, now actually what we can do, whenever a new message is added in the dead letter queue, we can specify a trigger. Okay, what that trigger do, that trigger is notifying the developer or the debugger team that there is some message added in the dead letter queue. Now you can check what is the issue and you can um, handle that issue. Okay, now there are two scenarios, in which scenarios like how a message can be added in the dead letter queue. Okay, in the first scenario, let's suppose I have so many consumers, but none of them is working. Okay, they all shut down for some reason. Let's suppose some error occurred at the consumer side, and no consumer is working for now. Okay, now producer keeps making requests and adding messages in the SQS queue, but now the message cannot be processed and processed by any of the other consumers we have, and now there is an retention period. Okay, that retention period says like the message is in the SQS queue but not able to process or get by any other consumers. Then after that retention period is over, that message is going to added in the dead letter queue. Okay, this is the first scenario. And in the second scenario, let's say our consumer is working, but and consumer is working and getting all the messages but not deleting them. Okay, there is some issue while deleting that particular message and they are not able to delete it. Okay, now the message is still again going to add in the deadline, again going to add in the SQS queue, as Ravi mentioned, which is after visibility timeout. Okay, so let's say after that visibility timeout, the message is again added in the SQS queue, and after some time, another consumer tries to fetch that message, and again they are not able to process it completely. Now the message is again going to add in the SQS queue. After some time, like there is a max retries count, we can specify also. Like after that count is over, the message is again going to add in the dead letter queue. So these are the two major scenarios where a message can be added in the dead letter queue. Okay, I hope you get to know all the features. Now we are going to move towards the advantages of SQS. Okay, so SQS is the service that is provided by AWS, and AWS ensures that as every services has multiple resources and they can handle unlimited number of messages or requests per second. Okay, so SQS also has some this kind of feature. It can handle unlimited number of messages at every second. Okay, so as I mentioned, SQS is a service that is provided by AWS. So it is available in every other regions, or let's suppose we are in Asia, so we can deploy our SQS in our Asian region and can access it more effectively. Okay, and also it ensures high durability and availability. Okay, so now the third advantage is my favorite advantage. Ravi also mentioned this, like SQS offers us loose coupling or decoupling, or it can be like more asynchronously working with the producer and consumer. For that, I'll give you another railway example. Okay, so let's suppose we have two services. One service task is to book all the tickets, and another service task is to send the email confirmation to the uh, customer or passenger. Okay, now a railway system is smart. They allocated more number of resources in the booking of tickets, and there are less number of resources in the email confirmation. Okay, now now the producer is making, let's suppose, in a million number of requests at every second. Okay, but now our email server is too small. Now they cannot process that number of requests at every second. Okay, now it now this process is asynchronous. Okay, now let's suppose email server is not able to process. No worries, they can get at their own pace. Okay, let's suppose they are making 500,000 at every second. They can get it and utilize the other messages at another time. Okay, so that is the best example I like about uh, our this third point. Okay, now we have some more advantages of SQS. The fourth one is I have already explained you the more features like SQS has to offer dead letter queue for error handling and delay queue and long pulling, short pulling, even the post based method. So these are the major advantages of SQS. Like it has so many features. It even has a strict ordering. If you want to use, you can use FIFO. If you don't have like a strict ordering requirement, you can use standard queue, whatever suits you. Okay. Now for the fifth example, fifth advantage, we have SQS is a service of AWS. Okay, so SQS can connect with other services like Lambda, S3, EC2, or many other. Okay, in this scenario, let's suppose I want to use a post-based method. How can I use it? Whenever a new message added in the SQS queue, okay, the SQS queue directly communicates with the Lambda and send that message to the Lambda. Okay, and Lambda can further process that message. And Lambda will be acting as a consumer in this case. Okay, so this is how SQS can communicate with any other services, and it will be like while you are configuring this service, this feature, it will be more easy to configure. You don't have to do much. You just have to link with them, and it will be directly working. Okay. In the sixth point, SQS is very cheap. I would say the first million request for every month is free. Like if you have a small amount of request for your project, you can use it even for free. So this is the great example. Okay. So further, we have a demonstration. Actually, I have implemented this XQS queue in the Python. Okay, I'll just quickly show you. So in we now here I will tell you I have two terminals. One terminal is the producer. I have code in which I'm always producing new messages. Okay, and another one is a Django server that I am running. Okay, it is a push based method example in which whenever I send a new message, and then the message is going to add in the SQS queue, and that particular message is fetched by the Lambda, and Lambda directly uh, tells me that message. Okay, here I'll quickly show you. I run that example, the message sent successfully. We will just wait for a couple of seconds, and that message is going to appear in this server. As you can see, that message is successfully retrieved. Okay, uh, it I have actually, while I'm making that request, I have sent some dummy data here. You can see. Okay, even my API is called retrieve lambda messages. Okay, so this is the one demonstration from my side, and I'll go for the another demonstration. Okay, in this example, I am going to use the pulling method. Okay, so I have this producer. Okay, this time producer always making some request, like it is I've added a infinite for loop in this for loop. That message, that producer keeps generating new messages. Okay, I'll just run this. That it is start generating all the messages. Now for now I have no consumer working, so that message is still generating. Okay, let's say I just run this one consumer. Okay, now it is start fetching all the messages one by one. It is going to fetch all the messages. Okay, now I'm going to use another consumer. Now both the consumers are working and both of them are fetching messages from the SQS queue. Now I'll just stop my producer because it is generating so many messages. I'll show you just now, and I'm going to run the third consumer also. Now the now we have three consumers. All of the three consumers are fetching and pulling the messages from our SQS queue. I'll show you our SQS queue. I have implemented a standard type. I'll just refresh it. You can see I have 78 messages available in SQS queue, and they are fetching. These are the consumers who are fetching continuously all those messages. So for this example, I want to tell you that like we can use multiple producers and multiple consumers for our application. It is all based on our requirement. Okay, this is the demonstration that I want to show you. Okay, now we will go back to our PPT. Okay, so by this I have completed the demonstration of our SQS queue with the Python. Now, if you have any questions, you can ask in the comment sections. And we will be explaining. Now we will be ending of this session. Thank you everyone for joining this session, and I hope you will get to learn something from us.